This video gives an overview about what is meant by frequency selective surfaces, different types of frequency selective surfaces, and their application. Frequency selective surfaces are periodic array of metallic or dielectric elements that has the capability to allow or block electromagnetic waves depending upon their frequency, angle of incidence, and polarization. This was first introduced in 1974 by B.A. Monk, and this is his patent. You can see here that periodic surface for large scan angles. And this is his book on frequency selective surfaces, which explains about theory and design. If you want to get more insight about frequency selective surfaces, you can read through the book. Depending upon the arrangement of metallic patches, they can be divided into low pass filter, high pass filter, band pass filter, and band stop filter. If the structure is like a periodic array of metallic patches like this, the equivalent circuit will be a capacitor. Here you can see that this green represents the metal. Green represents the metal and white represents the dielectric. So you can see here that two metallic patches separated by dielectric. So it will be represented by a capacitor. That is, it will act as a low pass filter. This is the response of a low pass filter. So if an electromagnetic wave is incidentally on this structure, this low frequency will be transmitted through it, and the high frequency above this cutoff frequency will be reflected back. And if the structure is like this slot, the green represents the metals. Here you can see that this will look like a inductor, that is the circulating current. So it can be represented by an inductor, and it is representing a high pass filter. So in this case, when an electromagnetic wave is incidenting, it high frequency will be passing through it and low frequency will be getting reflected back. So depending upon this arrangement, these can act as a low pass or high pass filter. Previously we have seen about the patches. Now we are considering the loops. Here you can see that the green represents the metal. Here you can see a square metallic loop. So this will looks like a series inductor capacitor, because this will act as an inductor, and in between these metals and the dielectric they will act as a capacitor. So it will act as a band stop filter. That means that within this frequency band f1 to f2, that will not be passing through the structure and it will get reflected back, and all other frequencies below and above f1 and f2 they will get transmitted through it. So this structure will act as a band stop filter. So if we consider the dual of this band stop filter, here you can see this green represents the metals and it is a dual of this structure. Here it will act as a parallel inductor capacitor circuit, and that means it is a band pass filter. That means within this frequency it will transmit the frequency and other frequencies will get reflected back. That's how these frequency selective surfaces are working. Based on the geometry of the structure, they can act as low pass filter, high pass filter, band stop filter, and band pass filter. These are some of the applications of frequency selective surfaces. First one is radomes. Radomes are the protective covers of antennas. Because of these filtering characteristics, they can be used as the radome structure, because they will be transparent to antenna operating frequencies and they will absorb or reflect all other frequencies. They can also be used in stealth applications. By properly designing FSS, they can be used as absorbers or scatterers. So they can effectively reduce the radar cross-section reduction and can be used in stealth applications. They can also be used in antenna performance improvement because of this frequency uh, selective selective nature. They can be used as a superstrate to improve the gain, bandwidth, and the directivity of the antennas. They can also be used in shielding machines in communication system. Uh, this is also based on the frequency selective nature of the FSS. They can also be used in satellite communication system to design the reflector antenna systems. So they can be used as a sub-reflector system in dual reflector antennas. Thank you. If you find any of this information useful, kindly support by liking, commenting, sharing, and subscribing.